All right, we're back. Sound is good. Music is bumping. All right, we're doing it. We're just gonna do it live. Do it live. So this is what we're working on. This is the perennial, the one. This is like the introduction to Solana programming. This was the one that was around when there wasn't a tutorial. Let me get the link for you. We'll post this in the YouTube description too, right? If you're watching on YouTube. Give me just a second. I'm gonna show off some new hot fanciness we got here. Oh no, what's that? We got some drawing here. We're gonna draw on our screen, so that's fancy, right? Yeah, I'm pumped. All right, so this is what we're doing. This is new to me. It's not new to me, but I'm not an expert on this. But I'm gonna learn, and we're gonna learn together. And what we're doing is raw Solana development. There's gonna be there's a part in this where we deploy a front end, but it's gonna be super basic. We're not gonna worry about learning any of that. This is just all about building a Solana smart contract, and this is not using Anchor. There's none of that business. Use Anchor, right? Use Anchor. But we're gonna go through this introduction so that we really understand Solana and how it works, how the internals of the smart contract platform. And I'm gonna be learning with you guys. We hit blocks. I'm gonna find people to come help us work through things because I think we're gonna hit some blocks. This developer environment is the same one I use on the Rust stream. So right now, all it really has installed is all it really has installed is Rust. I don't even have Solana installed here. We may hit some problems there because I'm on an M1 Mac. That may give it some issues. I don't know. My terminal emulator is iTerm2. It's not the default one, but it's fine. It's the same. You just open terminal on your Mac. It'll be fine. So you need to install Rust if you haven't already. We're not going to do that. We've done that in other videos, other streams. Yeah. So I'm going to give you a history. I'm old man Solana, right? I'm not even OG. I'm just old man Solana. I'm the old dude that's been around for forever, which is only a year and a half. All right. That's how long I've been active in the Solana ecosystem. In 2021, that's a long time. But I remember when this thing came out in January last year, almost a year ago. This was it. You had Solana docs. You had Solana docs, which weren't even this good because the Solana Labs team was busy building and not busy writing about things. And this has a lot more information than it did. So what happened was paulx, the man paulx right here. I don't know what he's up to right now. Last I heard, he was working on Mercurial Finance, but I honestly don't know for sure because I haven't kept up with him because he's not on Twitter. He's on Twitter, but he doesn't do anything on Twitter. And I don't bug him. From what I've heard, he's very nice. He's always been helpful to me back in the day when I used to chat with him every now and then. But this came out, I think, and this is just my memory, so I may be remembering this wrong. I think he wrote this on winter break. He was home from school and he was on winter break and he wrote this. But he's been keeping up with it, right? See, look, it's 11, last updated November 19th. Yeah, sorry, I need to turn Discord off. Give me just a second. All right. So, like when I didn't know what the heck I was doing. I still don't. All right. We're learning together, to be clear. Like this came out and everyone was like, okay, now this is starting to make sense, right? There's a few people that had figured it out on their own because they were just like that good, right? Like paulx, one of them, Armani, and all the Serum team, like all those guys, and obviously Solana Labs team, like they knew what they're like. They had the time and experience to dive in and figure this out. But this was a huge thing. Back there was one other tutorial that was like a voting program, and I think that was by a guy MCF, and I don't. He's there's a validator still exists with that name, so I think he's still around somewhere, but he's not. I don't think he's terribly active on Twitter either. But I think that tutorial is no longer, it doesn't work anymore. I don't think. I could be wrong. But we're doing this, right? We're going to do, and this is an escrow program, smart contract. And we're going to talk about program, smart contract. They're the same thing. And unfortunately, I think I use them interchangeably, but they're the same. If ever I say Solana program, just know that smart contract and Solana program are the same thing. They're both on-chain programs. Okay. I realize this little thing, I need to get rid of this. I don't know how I get rid of this, my little screen here. Can I just, I don't know. Here, I want to make sure when the time comes, you can read this. Hang on. Window management. I need to install something on this Mac. There we go. Okay. All right. So normally, if you're going to write a Solana smart contract or program, you're going to want to use Anchor. We're going to go through this together so we learn how this all works, like raw Solana, okay? Yeah, so we're just going to read through this together. We're going to have to take a quick detour and install Solana on my dev environment, so that's fine. We're just gonna we're gonna take our time for this. I don't know how long it's gonna take. I have a couple hours, I think, that I can stream, and if that changes, I may have to drop early. But we're gonna get as much as we can here, and then it's all gonna go on YouTube, and we can watch it. You can review later. Trying to see. Yeah. Okay. I was just checking Twitter to see if we had any more interest. Looks like people are interested, but I don't know if there's anyone here on Twitch. That's cool. All right, so let's I'm gonna probably overuse my new drawing tool here, but I think it'll help us kind of focus on what we're trying to learn. So I just this is the one thing I worry about. I want to make sure this is visible or easily readable, I should say, because I know my screen's kind of ridiculously wide. This terminal, we're not going to spend a lot of time here. We're just going to get Solana installed, but we'll get to that in a little bit. So let me just break this out a little bit. There we go. Okay, so this guide is meant to serve as an intro to coding on the Solana blockchain, using an escrow program as an example. Oh yeah, I gotta switch. I'm telling you, I'm going to overuse this this drawing feature. So this is an escrow program as an example. So what's an escrow? An escrow is when there's some type of exchange, and it's not like a like for like exchange, or it may happen asynchronously. So like Deebs is the GROM's club lead with me, right? If Deebs wanted to, let's say I had a Thugbird and Deebs has a DGen8, right? And let's say Deebs and I don't trust each other, which we happen to trust each other. Let's say we didn't. Like I want to trade Deebs his DGen8 for my Thugbird, and he also wants to trade me his DGen8 for my Thugbird. We don't really trust each other, so if I want to give my my Thugbird to Deebs, how do I know that he's gonna give me that DGen8 that he promised? Well, in this instance, we would use an escrow, and this actually happens a lot in traditional banking or TradFi or whatever. Frequently with houses, you have to there's always an escrow. If you're buying a house. So basically, let's just do A for me, and D for Deebs, and then E for escrow, right? And so what happens is I give my Thugbird to the escrow, and the escrow tells Deebs, hey, Adam has given his Thugbird. And then so Deebs says, okay, well that's cool. I trust this escrow, and so Deebs gives the escrow his DGen8. And then so once the agreement has been made, according to the escrow then distributes the DGen8 to me and the Thugbird to Deebs. And that's basically it. And so what we want to do, like what the goal of this program or smart contract is, that it's an on-chain escrow, right? It's not a person. Like, so if we, this actually happens a lot on the NFT markets or even the Discords, is that they're called peer-to-peer trades, right? And before, like sometimes to avoid market fees or whatever reason, people do these peer-to-peer trades, and they don't they don't trust each other, they don't know each other, they don't even know, like I could be sending a picture of my DJ or my Thugbird that's not real. So what some people do is rely on another trusted like Discord member to serve as the escrow, and so that Discord member will take the initial token, whether it's a NFT or maybe some USDC or Solana, and it will verify that it equals what the agreement equals, and then it will take the other part of the trade from the other trader, and it will then distribute those. So we've seen even that not work out, where the escrow was actually colluding with one of the traders, and then one person was left out. So this is the value in like an escrow smart contract, is that we can trust a smart contract more than can we trust people, right? Because anything could happen with that person. Like they could be somebody. I think that's one thing I read about recently, was that there was a Discord member that was impersonating a legit Discord member that people trusted. But with code, maybe we can avoid that, right? All right. So that's our escrow. So we're going to go through the code together, build the escrow program step by step. I've also created a UI you will be able to use to try out your program. Additionally, you'll get to play with the SPL token UI. So this is something paulx has created. I don't know if I'm assuming it's up to date. I haven't looked at it in a while. So you can just create a token here. Yeah. More info in this blog post can be found somewhere in the docs or in example programs. Having said this, I have not found a guide that both walks through most of the coding theory step by step and applies it in practice. So this is like kind of what's tough about Solana is like the docs here serve the purpose and they give you information about the programming model and kind of like what are the technical definitions of some of these terms, but they don't necessarily like give you the context necessary for like putting it into use. And so that's what this blog post aims to do. Give me just a moment. All right. So yeah, it's not going to be a Rust tutorial. So we may have to learn some new Rust concepts along the way. That's fine. This is talking about the layout, important theory, like we'll be sprinkling the posts like this. So whenever we see this, we should like really kind of internalize whatever's in this little breakout bar or whatever you want to call it. On Solana, smart contracts called programs. People still call them smart contracts, so I don't know. We'll call them smart contracts and programs. I'm going to try to call them programs because I like that. I like Solana programs better. At the end of each section, summarized like this. There's a summary on Solana Smart. All right. I'm going to claim to explain all topics, of course. But yeah, it's a good starting point, right? And that's where we want to be. Something is not working here. You just got to have a look at the final code here. So we have I'm just going to open that. We won't go to it for now. You can find Paul on Discord or on Twitter here. So before we start coding, let's look at the final product to understand what we are building. Hold on. Before we go I want to go through this. I want to make sure. Yeah, so I need to install Solana first. So let's do that. Hang on. Sorry, I'm just getting the command to install Solana. I think this is what I want. Yeah, here we go. Install Solana tool suite. Yeah, so this is for version 1.9.2. I'm actually going to see if I can get the same version that paulx uses because I don't want to deal with any like compatibility issues while working through this. What's most important is that we're learning, right? We're not trying to make the latest and greatest version work. So I just scrolled down to the picture of his cargo.toml file, and if we note here, he's using version 1.6.9 as a dependency, which I think coincides with like the version of Solana. I should probably just make sure, and ideally these things would be like compatible, but I don't know for sure, and I'm kind of don't want to find out later down the road. I don't know. Maybe it's fine. So I'm just scrolling through all the versions of Solana. Now I'm kind of like, ugh, I don't know what to do. If I should install 1.9.2 or which. Let's go to the crates.io. That'll tell me. Look at Solana program. So if you notice what he's got this dependency from cargo.toml. It's a Solana program 1.6.9, and I want to see what version. Yeah, see, look, that corresponds. This 1.9.2 corresponds with what Solana mentions to install as the latest version. Yeah, so I'm gonna go ahead and try to install 1.6.9. If we have problems, we should be able to upgrade, but we'll see. So, like, this is one thing that I have a hard time keeping track of, and I've stumbled over a couple times. So, I'm on my machine. I'm going to install Solana, right? It's going to be a version of Solana. So theoretically, I can install this latest version here, this 1.9.2, right? And that's one thing. And then in this program that we're going to write, if we match our car.toml file, which we will, we use version 1.6.9. Now, so what that means is that that doesn't necessarily mean it has to find this local version of Solana running 1.6.9. What that means is it's going to go get the crate here, Solana program version 1.6.9, which, if we go back a few days or a few months rather, it's around here somewhere, I guess. So there's these different stable versions. So it's not listed here. 6.9. Oh yeah, there it is. 8 months ago, 1.6.9. That's right. I forgot. So yeah. So this is an old version. One thing I am concerned with, and we might be able to address this, is if we notice in here, this is 2018 version of Rust edition. So I don't know. I'm pretty sure I have 2021 installed. So I should be able to install another version of Rust, right? So to be conservative, I think the right thing is to go ahead and install my local version to match the dependency version we're going to pull in. So let's do that. Oh yeah, so that's not even a release. Well, let's go to the releases here. Uh, 1.6. So this stable release is close, so I'm going to try that one. So 1.6.14 is the stable release. No, why didn't... Oh, I guess I can't just install that one. It's not like an install version, maybe. Can I do this guy? It's pretty close. Stable release. Let's try it. I just want to get close. I don't want to have any surprises, but may just have to deal with them. Okay, so that one's working. Fingers crossed this works out for us. So that's going to take some time. Let's just add this to my path just to... Now I should get, yeah. Yeah, so I get all these Solana commands. 1.6.27. So that'll be slightly different in the version in our program dependency. Hopefully that won't cause us any problems. But if we see something later, let's try to remember there's some version difference there, but I think we'll be okay. Okay, so let's get back to this, right? I think that's all we need for now to install. Yeah, so this is just talks about what an escrow, like we talked about. So it's a good overview of what we can expect. This is like the functional layout. As we scroll down, you'll see like the practical layout using Solana is actually a little different or a little more complex. Yeah, I don't think we need to read this. This is what we talked about. And only that, yeah. Blockchain ways to replace a third-party seed. So when you're developing like blockchain programs, this is something you want to really internalize. Blockchain ways to replace the trusted third party C with code on a blockchain, specifically a smart contract. Right. We don't want that third party C to be like a server. Like you can do that, but it's not really, that kind of defeats the purpose, because then that centralized server is a point of failure, a critical point of failure. Yeah. So this is right. If you really if you're working with someone and you want to trade with them, if you're sophisticated enough, you can actually inspect the contract and make sure whatever escrow you're using is, it's going to do what you expect it to do. That's another possible attack, right? Someone let's say there are some escrow, I think, like peer-to-peer or P2P NFT trading sites that arose. One way to do that, to attack that, is if I let's call it like peer-to-peer swap, right? If let's say that's the name of the site, maybe if peer-to-peer swap became known as a good escrow site or whatever, I could make a site that looks like peer-to-peer swap and then change the contract to where it does what I want to do instead of what the users expect. So that's like a kind of possible attack, even with the smart contract in place. That would be kind of like a spoofing attack, I guess you could say. Cool. All right, man. I don't know if I have GitHub set up for this, but we're going to try it. I think I do. Yeah. Okay. So we're going to get this template repo. So this is by Vines. He, last I checked, is an employee at Solana Labs. I don't know why they haven't made this kind of a de facto template, but here it is. Yeah, see, this another concern I have is update to Solana version 1.9.1. I'm worried that I'm gonna get I'm gonna hit some compatibility collisions or whatever. So I don't know. Maybe we'll have problems. Maybe we won't. All right, so we're gonna use this template repo in GitHub, and I'm going to let's just call it Twitch escrow. Go for all intro to Solana program. So what this is going to do is just going to create a new repo that copies this template repo, and it's going to name it Twitch escrow and it's going to create it on my GitHub account. I'll just wait till that finish, and then I'm just gonna pull this down. Make a code dir. Oh yeah, of course it does. So I'm just gonna git clone. This is my version of that template repo. I'm gonna clone it down. I'm gonna open Visual Studio Code. Yes. See, look, this is what I'm worried about. Look. Oh, look at this. Fancy. What version do we use? I forgot. We use version 1.6.27. Okay. Let me go ahead and close my terminal because I think we're good for that for now. We have some issues with it here. We'll address those a little later. Okay. So I've got my own Twitch escrow repo here. And Solana, this is what we've got for now. If you're on Mac, the version you want to build from source section. Okay, we don't need any of this right now. I think we're okay. If you don't know how to test Solana programs yet, remove all testing code. Testing programs is another topic for another blog post. Still waiting, Paul. I never saw that blog post. I'm just kidding. So we're just gonna clean up our TOML file to match this here. We don't need this. Yeah, that's good. That matches his, right? We'll change this to 2018. That may give us some problems, but we'll see. Let's just rename this to match our repo. Okay. All right. So I think we're good here. Yeah, we got our. That's happy. Yeah, I think we're okay. Okay. Have a look into lib.rs. He also said to remove the testing code. So I'm going to remove all the testing code down here as well. Obviously, it's important to test, but we're not there yet, right? We want to keep our focus as tight as possible for now. And right now, we just want to learn. We're not gonna. This is not for deploying an escrow account that everyone's going to use, right? I mean, you could build on this if you want to, but right now we just want to learn. Give me just a second. I'm going to mute. Okay. First required crates are brought into scope. I'm going to hide this for now so we can see all this. I want to I'd like to break this up some into a multi-line use statement, but I have a feeling when I save this, it's going to correct it back. Okay, it didn't. All right, good. Just so we can read that easier. I know my font's really big, so we don't have a whole lot of real estate for our code, and I don't like when stuff's cut off. All right, the first required crates are brought in scope using use. Then we use the entry point macro. Okay. So we've talked about use in our streams. We've talked about crates. This is probably maybe some different syntax than we've seen before. I don't remember, but what we do know, we can know here is that this is our crate, is the Solana program crate, which we saw in our cargo toml file right here, right? And then we have our various modules within the Solana program crate, which, I think yeah, just break that up. Account info. We'll dig into these. I think I don't think I need to like walk through each of these yet. Maybe we'll see. So this is the entry point macro, and what that really kind of functions is our main function. It might be worth looking at this. I don't know how helpful this is going to be. Yeah. Okay. So this is actually new. I don't think this was here. I could be wrong. There we go. That's what I want. So let's just go back to look at that. Entry points are the only way to call a program. All calls go through the function declared as the entry point. I kind of want to take a step back here because I feel like there's some stuff we haven't talked about that's probably important. We should talk about let's talk about that before we get into this entry point, into the code here. So I think one thing I don't want to take for granted, I'm trying to think of what's a good way, maybe I can just draw this here. So let's just hide this for now. So let's think about our Rust program, or our Solana program, right? So there's this is horrible. Ignore that. Right. I do not have this set up very well for being left-handed. Let's just call this a blockchain, right? And these are just blocks. And what are blocks, right? They're just like examples of state, right? So account 1 has 5 SOL, account 2 has 2 SOL, account 3 has 4 SOL or whatever, right? And then there's a trade happens in a block, and then there's a new balance for all those accounts, right? Excuse me. So when we're on our computer here, writing our smart contracts, that's a computer, right? And clearly a keyboard. At some point, we're going to send our smart contract, our Solana program, to the Solana blockchain. So I think what we need to keep in mind is that as we're working on our program, the end state is not that this program is going to run our computer. Our program is going to run on this blockchain. And really what that means is that there's all these cloud computers, called validators. And I say cloud, they're not necessarily just in the cloud. I guess some people run them at home, but they're in data centers, right? There's all these cloud computers that are validator computers. And so when our smart contract, and they're the ones that are producing blocks, right? This guy will produce a block. It's not this simple, right? But this will work for what we're doing. So the different validators are producing blocks. And one way they produce blocks is they run transactions that go through our smart contracts or our program. So maybe it's more appropriate if we think that our there's this group of validators. Oh, that's so bad. This is like a circle around our validators here. There's a group of our validators that we actually send our smart contract to, and they save it in their memory. And then whenever the smart contract is called, either by a computer or like a web page, maybe there's like a website where I go and deposit Sol, like that will call, my smart contract that I uploaded. And then that smart contract runs on these validator machines. One of them, depending on the block orders, all that stuff that we're not going to worry about right now, just know that it's like this group of validators. They'll run those transactions based on the instructions we've uploaded in our smart contract. So I hope that makes sense. If it doesn't, I think it will over time. But it's just important to know where our smart contracts ultimately run. We're going to write them on our computer down here, and we're actually going to run them against test validators that are running just on our machine before we actually deploy them. This is what we call deploy. My handwriting's horrible. I have no business doing this. Deploy. This is the deploy process. So we deploy our smart contract. We're going to go to testnet or devnet or whatever. But then once we're going to go to mainnet, it's going to happen, and our contract is going to be sitting up there, going through whatever programs are necessary. Or going through whatever instructions are necessary. So our smart contract, like there's a couple parts to it, and I don't feel if I have it understood good enough to like walk through it now, but some elements that I think will be clear are there's like a certain amount, there's instructions, right? These are, this is a lot of the code we're writing. And that means like when a website interacts with our smart contract, it can call these instructions. So like within an escrow, how do I get rid of this? Let that fade away and then bring it, freeze again. So an escrow account, we're going to make this big just so I can try to, our escrow program, it's just going to be kind of sitting up there. This is like, so let's say this escrow smart contract, we've already written it and deployed it to mainnet, and it's working fine. It's just kind of sitting there. And then we, it's anything can interface with it, right? A wallet, let's just say like a mobile wallet, I for iPhone, I guess, a web browser, and our little phantom guy. God, how do I draw a phantom? And our phantom wallet, they're interacting with our like they can now interact with our escrow contract. It's all doable. So if they so let's say these two are trading, a Thugbird and a Degen Ape. When this iPhone wallet sends the Thugbird to the escrow contract, now that the escrow contract has a Thugbird and it's waiting for the Degen Ape. So we send that Degen Ape to the escrow. That actually causes some things to happen, right? And what happens is the escrow contract sends the Degen Ape to the iPhone, and the Thugbird gets sent to our Phantom wallet, right? I'm really just using this as an excuse to use my tablet here. I think that helped. So let's bring our code editor back up. So what we're programming when we're working on this is like that contract that's going to end up on the blockchain. That smart contract or programs get on the blockchain. Oh man, we're getting into some fun stuff already. So we may need to bring back our fun uh, tablet drawing thing. So the only way to call program is through the entry point, and that's right here, and it's this process instruction. So what happens is the entry point macro. Remember that macro is like just like our print line. It's just like it's short. It's a short an abbreviation of code is, I think, maybe one way to think about it. And then it's gonna send this. It's gonna actually pass this function process instruction into the entry point. Okay. Entry points are the only way to call a program, aka Solana smart contract. All calls go through the function declared as the entry point. When called, a program is passed to its Bpf loader, which processes the call. Different Bpf loaders may require different entry points. Okay. Let's not worry about Bpf for now. Okay. I don't think we need to. I don't know it. I don't like. I have this kind of understanding of it, but I don't know it. That like what Berkeley. It's Berkeley packet filter. I don't think that we need to know like kind of like about Bpf to go forward from here. If we do, we'll circle back and learn about it. But for now, what we are going to learn about are this loaders. And so these loaders actually sit. Let's read through this. So this Bpf loaders actually sits on the blockchain, and there's one. Excuse me. There's two, right? There's actually two. There's this Bpf loader and Bpf loader deprecated. And these are actually programs sitting on the Solana blockchain. So let's read about this. The Bpf loader is responsible for loading, finalizing, and executing Bpf programs. Not all networks may support the latest loader. What does it mean by networks? It means different versions of Solana, or different Solana network instances. So mainnet beta is the one where we throw real money around, and then there's like DevNet and testnet, and then you'll have your own local version too. You can use the command line tools to check if this version of the loader is supported by requesting the account info for the public key below. The program format may change between loaders, and it is crucial to build your program against proper entry point semantics. So if we remember back here, when called, a program is passed to its Bpf loader, which processes the call. This is what we're doing here, right? This is actually like our this is really the program. This is all of it right here. And so this function, this process instruction, is what we're passing into entry point macro. And the entry point macro is specific to this Bpf loader that we're using. Let me see if I can draw this. I think this would be helpful if I could. If I can accurately represent it abstractly enough that we can understand it. So we have, I'm trying to think like what's a good way to like represent our blockchain. I guess this works, right? This is like, oh yeah, I gotta make sure that sticks around. I think this is a good way to visualize it, right? And what we should know is that this is like time is moving this way, right? as time goes on, more blocks are produced and more like state is produced. So in this, like part of all of Solana, right? There's all these smart contracts that people have written and deployed. But there's actually like there's a couple important ones that are not just like DeFi or NFT smart contracts or whatever. There's actually like a couple smart contracts that have some special privileges because they enable functionality. They enable functionality that just they have privileges and enable functionality that we can't do with just any smart contract or program. And so what actually happens is, remember our computer here. It's our prompt. This is our computer and keyboard. We're working on our smart contract and program. And when we deploy it, as we saw here, oh man, I can't. Hang on. What did it say here? Where did it say that? We're looking that up here. Yeah, I think it said it here. Let me zoom this up a little bit. We're loading, finalizing, executing Bpf programs. So when we deploy our smart contract, let's just say our little escrow smart contract, it goes here. And the Bpf loader has put it here, right? And then when something trips, calls the escrow smart contract or whatever, the Bpf loader is actually responsible for executing this smart contract. So it'll say, and then our smart contract will spit out NFTs, our degen ape or a thug bird or whatever. So what's important to know here is that this is just a smart contract, right? It's a little different than anything we will deploy because it has its own privileges in order to do these things, but it's all running on the blockchain, so it's it's not centralized, and it's enforced by kind of validator consensus and all that. I think that's hopefully as deep as we can go. And the reason we're talking about this now is because this Bpf loader has a certain amount of syntax necessary that we have to adhere to in order to access it. And so for this specific Bpf loader, this one's just an old deprecated, means it's no longer supported really. I don't know if you can still run programs through it if you really want to, but you can probably access programs you deployed a long time ago through it. But sorry, I lost my train of thought. With this Bpf loader, we have to use this entry point macro here, and this is actually some good information here. I think it gives you kind of the signature of the function you should pass in. Yeah. So that's an important concept to understand as we go forward. So let's read through this again. The reason for the existence of multiple Bpf loaders itself is a program. If updates are made to the program, a new program version has to be deployed. We can see that the Bpf loader we are using requires entry point function to take 3 arguments: program ID, is simple. Let's actually like put some comments in here. This always helps me. Program ID of the currently executing program. We're gonna have a lot of comments on here just to kind of help us keep everything straight as we're reading through it. Yeah, so it says why you'd want to access it inside the program will become apparent later. So this is like the program idea of this actual escrow program, if I'm understanding that correctly. Instruction data. Oh wait, actually, accounts happens first. So accounts, we'll just put account info for now. This is what we're going to talk about coming up, I think. Instruction data. Why do you want to access inside the program? It's data passed to the program they call it. It could be anything. Okay, so this is just like when someone calls our smart contract, this is the data that we'll need, whatever it is, like maybe it's like an address or an amount or something like that. To program by caller. Okay. So now we have to understand what accounts are. And that's, this here. We have to dive deeper into the Solana programming model. The reason we need accounts is because Solana programs are stateless. So Solana programs are stateless. What's a good way? So I guess I'm trying to think of a good way to like talk about this. I'm gonna go this and see what we got. Here we go. That's interesting. This is actually a really good way to talk about it. This is really good. Wow. I need to like this stuff. I don't think we need to talk about because that's like unnecessary. Oops. I don't need this. Get this out of here. In a stateless environment, you always send along all the information needed to finish some task. So what that means is that this smart contract is going to be sitting on the blockchain, and it's not going to have like the data that it needs to run. So it's just kind of like it's just the logic, right? But there's no data for that logic to run on. Yeah, I think I'm trying to think of like a good way to talk about this. So like our, let's say our escrow. Yeah, this will work. All right, we're gonna go back to the drawing board. Let's get rid of that. So let's say we have our escrow program here, right? And we remember what our escrow does, right? It allows us to, this is just our escrow program sitting on the blockchain. And again, let's remember that the escrow program, it allows us to trade like a peer-to-peer trustlessly, right? Well, when we talked about it, it was me, Adam Del Sol, and Deebs trading our, I just made this really big. Can I go back? There we go. Oh man, how did I make that so big? All right, that's better. Hang on with me, I'll line this. I have my Thugbird, and Deebs has his degen ape, right? And we had this whole interaction where I send my Thugbird to the escrow, Deeb sends his degen ape to the escrow, and then the escrow sends me the degen ape and sends Deebs the Thugbird. And so now I have a degen ape and Deebs has a Thugbird, right? Well, so this escrow program, it didn't. It's just sitting there. It didn't know when it's up there. It doesn't know before Deebs and I interacted with it. It doesn't know that Deebs has a degen ape that it wants to send to me, that he wants to send to me, and it doesn't know that I have a Thugbird that I want to send to him. Right? It's kind of like it's just there with this logic. And so what that means is, let's trying to think of. So what that means is now this escrow program is here. It's not specific to me and Deebs. It's there, and so that means if, let's say, Anatoly comes along and Raj comes along, and Anatoly has a GROM and Raj has a chicken tribe, Anatoly can send his GROM, Raj can send his chicken tribe, and the escrow account will send the chicken tribe to Raj, or to Anatoly, and the GROM to Raj. So this escrow account, it doesn't know Anatoly. When I deployed this escrow program, it doesn't know Anatoly's address. It doesn't know Raj's address. It doesn't know he has a chicken tribe or a GROM he wants to send to Raj. He doesn't know that Raj has a chicken tribe to send to Anatoly. Doesn't know that Anatoly has a GROM he wants to send to Raj. They don't know that this trade wants to happen. And so in order for us to call this escrow program, we have to give it that information. Whoever is the first person to initiate this escrow, they have to give the information to the escrow program. Say, hey, let's say, let's just clear this out, some of this out, right? I guess I could have. So let's say again, Anatoly has a GROM, Raj has a chicken tribe. If Anatoly wants to initiate this trade, not only does he have to tell the escrow program, hey, I'm sending you a GROM, but he also has to tell the escrow, I'm going to send you a GROM, and when Raj sends you a chicken tribe, that means that you send me the chicken tribe and you can send the GROM to Raj. Okay? So the escrow program is dumb in that it doesn't have any of that context. It's stateless. It's not and so like whatever state there is has to be held elsewhere in what are called accounts. And this is a big part of the Solana programming model that, I'll be honest, I haven't completely grokked yet. But we're going to work through that and get there. I hope this is helpful. It's definitely helping me figure these things out. Let's get rid of that. Let's get our code editor back up. We may have to come back here and talk about accounts, but that's fine. So if you want to store state, use accounts. And accounts are, I don't know if it's appropriate, but they may be more appropriate, may more appropriately be called files. I don't know. But regardless, essentially all data on the Solana blockchain, including programs, which the instructions and everything are the actual logic is data as well, are owned by accounts. They're stored in accounts which are marked executable. So let's look at this this Solana documentation. Make sure this is readable. The program needs to store state between transactions. It does so using accounts. Accounts are similar to files in operating systems, such as Linux, in that they may hold arbitrary data that persists beyond the lifetime of a program. Also, like a file, an account includes metadata that tells the runtime who is allowed to access the data and how. Okay. Unlike a file, so here's some good distinction. Unlike a file, the account includes metadata for the lifetime of the file. That lifetime is expressed by a number of fractional native tokens called LAMP ports. So just if you're not familiar, LAMP ports are the smallest, I believe they're the smallest denomination of the Solana token. Accounts are held in validated memory and pay rent to stay there. So our accounts that sit in validated memory, they hold our programs, they hold our tokens. We have to pay rent to stay there. Each validator periodically scans all accounts and collects rents. Any account that drops to 0 LAMP ports is purged. Accounts can also be rent exempt if they contain a sufficient number of LAMP ports. So let's put the second part, the second paragraph to the side. I just want to focus on this, and really, we really gotta get this. This has to become intuitive about what these accounts do and what their role in Solana development is. And I'm still working on that myself. So I'm going to read this again, just so we can kind of go through it. If the program needs to store state between transactions, so let's do that. We're going to go back to our drawing board, and we're going to have our escrow program again. Oops, I need to make that stick around. We have our escrow program. I'm going to make that a little thicker so it's readable. There we go. Now it's too thick. So that's our escrow program. If the program needs to store state between transactions, it does so using accounts. Well, remember what we were just talking about? So let's get our trade again set up. A has a thug bird. Deebs has a GROM. And we're going to use the escrow smart contract that's sitting on the blockchain, right? That'll be the blockchain. I don't know what that is. So when I'm going to be the initiator, and there's a term, I forgot what Paul uses in this tutorial, but I'm going to be the initiator of this escrow, okay? And so what I'm going to tell the escrow program is, hey, we're going to do two things from me, right? This is going to be, I'm going to send it state, actually. And part of that state is the data, right? And so that state means, what is that state is that, I'm not going to write that out because you won't be able to read it. But that state is the fact that, hey, I'm going to send you I want to set up a trade between Deebs and I. I'm just saying this in plain English of what the information, the data and state I'm passing to this escrow program. This is not true. I'm misusing the word state. I'm going to send the escrow program. So let's get rid of that. State is not the proper term at this point. I'm going to send the program some data, and that data is my account. There may be more, and we'll see what data specifically happens at this call. But I'm calling this program with data saying, It's going to send my account. It's going to send my address and Deeb's address. It's going to say, part of that is going to say, I'm sending a Thugbird, this specific Thugbird. And when you receive Deeb's GROM, I said DJ earlier. That's fine. You get it, right? These are just NFTs. And I shouldn't even use NFTs because this tutorial is actually just like fungible tokens. But it's on theme, I guess. So the Thugbird, so when I send you my Thugbird, and hold on to that Thugbird, and then when Deeb sends a GROM, you may then send my Thugbird to Deeb's and give that to him, and send Deeb's GROM to me, and now that they're mine. Okay, so that's data, right? That's the data that we're calling this smart contract with. Now, there's going to be a couple steps, right? And this is a simple version of it. So this is like step 1. Let's just do that, right? I'm calling the Escrow Program with the information that about the trade that I want to happen. And then in step 2, I have sent the escrow a Thugbird. And so the escrow now has a Thugbird. And Deeb still has the GROM. Right? And so this is state. The fact that the escrow has a Thugbird and it is waiting for a GROM from Deeb to do anything is state. That is the state of this trade. Okay? Sorry. And so we need to store that information because the program, remember, this escrow program is just the logic. Okay? So that is, so somewhere this state, the fact that the escrow program has the Thugbird and that when Deeb sends its GROMs, it knows what to do, that is all state that is held in an account. And I can't, oh man. Let's not mess that now. Where we go? Okay. Let me just go back a little bit here so we can. This is an account that's going to hold that state, right? And accounts hold other things too. They actually hold our escrow program. There's going to be a separate account for the program itself. That's an executable. So let's fade that out and bring in the third state, right? Or the third step. It's not a state, but it is. There's a step now where I have nothing because I've sent my Thugbird to the escrow, and Deeb's has sent his GROM. So the escrow actually has the Thugbird and the GROM. So this is another piece of state, right? These parts are actually the state. And then that state is held by an account. Okay. And then, well, what's step 4, right? So these things actually happen pretty quickly, but just for, our different steps. I don't know. I got a GROM back. And, so it sent me that. And then probably, this actually can happen in the same block. So it'd actually be one step, but just for illustration purposes. I still have my GROM. And Deeb's has been sent his Thugbird. And so these are all different. These different steps illustrate different state that needs to be held in accounts. Because the escrow is holding its own account. It's just the logic. Okay. I hope that's helpful. Like, I'm digging into these things because they're like important topics, and they're going to be important the whole time you're developing. You're developing on Solana. All right, so let's get rid of that, and we're going to read this. I'm not going to bring the code editor in case until I think we need to type some more code. Once you store state, use accounts. Programs themselves are stored in accounts which are marked executable. Each account can hold data and SOL. Each account also has owner, and only the owner may debit the account and adjust its data. Crediting may be done by anyone. Here's an example of an account. As you can see, it has system program. I can't assign program ID. That's interesting. Anyway, so let's just go back here. I'll zoom in some here. Each account can hold data and SOL. Each account also has an owner, and only the owner may debit the account and adjust its data. Crediting may be done by anyone. So we know this how public keys, public key infrastructure, generally works with Bitcoin and most cryptocurrencies. Anybody can send money to a wallet. Only the person who has the private key can withdraw or debit the account and adjust its data. Okay. As you can see, the example account has an owner field set to the system program. So here it says assign program ID. I wonder if this field has been changed. If the label that's being used, it was previously owner. Let's actually just open this account in Solscan, I think. Actually, I'm going to keep this up here. Come on, where's my dark mode? I don't know if Solscan will actually show this. No. Oh, interesting. This is actually a stake pool. Okay. Anyway. Yeah, I think what assign program ID, I think where this terminology may have changed. It has its owner field set to the system program. So assign program ID. I don't know. Accounts can only be owned by programs. So this is an important part. This is where it gets tricky for me. So programs are stored in accounts, and accounts can only be owned by programs. Okay. Now, you might be thinking, does that mean my own Sol account is actually not owned by myself? And you'd be right. If you're not, your funds are safe. The way it works is that even basic Sol transactions are handled by a program in Solana, the system program. As a matter of fact, even programs are on programs. Now, so this is another special program. Let's actually see if we can just go to that. So the system program with this address is actually owned by the native loader, which is different than our Bpf loader. Actually, can we pull up the Bpf loader here? I think we can. Yes, we can. Maybe this is the old one. This might be. Hang on, we got our BPF loader. No, BPF loader 2 is what we want. Okay. We want this BPF loader 2. What's this upgradable? I just saw that BPF loader. Oops, upgradable loader. So these different programs, the system programs, are various BPF loaders. These and our native loader, which is 1, 2, interesting. These are all like special programs. See, as a matter of fact, even programs are owned by programs. Remember, they are stored in accounts, and these executable accounts are owned by the BPF loader. The only programs not owned by the BPF loader are, of course, the BPF loader itself and the system program. They are owned by the native loader and have special privileges such as allocating memory or marking accounts as executable. So this is a lot here, right? Just know that we have a couple a couple of special programs sitting on Solana blockchain that enables a lot of the functionality. One is a system program. The others, some others are these BPF loaders, which are different versions that we've seen. BPF loader 2, the upgradable BPF loader, and all of them are owned by the native loader. Okay, wait, it's all programs. Always has been fun. You look at the system program, you'll see that although the program owns all basic SOL accounts, it can only transfer SOL from an account when the transaction has been signed by the private key of the SOL account being debited. So I'll see if I can draw our way through this because I'm so good at it. I'm gonna get a little speculative here and kind of like try to articulate my understanding of things. So we know a Solana wallet, right? We have our Solana wallet, right? And there's two kind of important pieces to that, right? There's the public key, and there's the private key, right? Just make this simple. And so these are like just cryptographic elements, right? And so when you have Solana, so you have like a SOL, let's just say like I have 5 SOL, right? Right. So somebody can send me SOL to my address, right? They don't need anything special. But in order for me to send that SOL anywhere, I have to use my private key. Well, this account here that's not any better. This account here is not owned by you. It's owned by the system program. And when you want to send Sol, you actually send a message to the system program saying, you know, my account that has 5 Sol in it, I want you to send that 5 Solana to, I don't know, let's send it to Deebs. Deebs is public key. And that actually doesn't go to Deebs, right? It actually goes to another account. This is my understanding of the way Solana transactions work. You don't actually like this. You can't do this like just straight to Deeb. You can't like sign this message. So if I'm remembering correctly, Bitcoin, the Bitcoin network, it you sign a message and then that gets broadcast to the gossip network on the Bitcoin blockchain. Let me clear this up and try to like try to talk through this. So let's see, BTC. Let's see. Let's just do private key for now. You know, and there's like these circles are all like Bitcoin nodes, okay? And let's say I have 1 BTC. And let's say I want to send 0.5 BTC. You know, there's all the UTXO thing and all that stuff, but we're not worried about that right now. I send this message to these, you know, I'm going to send it to Deeb's pub key. I basically broadcast this message to all these different nodes that I'm sending 0.5 Bitcoin to Deeb's, and then Deeb's has you know, 0.5 BTC on this shared state, right? The ledger, the Bitcoin ledger that all these nodes share. And then that, you know, it obviously has to get mined and all that stuff, but that's kind of, you know, it's this gossip network thing. But from my understanding, and I'm going out on a limb here, what we do in Solana is we have our private key. Our private key. And we send, you know, if we have 1 Sol, that's on an account that's associated with my private key, but owned by the system program. So the system program says, I know that you two guys go together. The system program has that in its memory. And the private key says, I want to send that point Sol. Let's just do Deeb's. You know, he has his account here and his pub key, private key. And so I want to send 0.5 Sol. So I send a message to the system program. The system program says, okay, I am going to take 0.5 Sol and move it to Deeb's account. This is my understanding of the way, you know, now I have 0.5 Sol here, the way Solana works. And remember, this is just an account that's associated with Deeb's public key. It knows that these two guys are related. Okay. So that's that's a system program, and that's why we need to know about it. or I mean, that's not all of the system program, but that's like kind of what we need to know at this point. In theory, programs have full autonomy over the accounts they own. It's up to the program's creator to limit this autonomy and up to the users of the program to verify the program's creator has really done so. We'll get to how a program can check whether a transaction has been signed and how a program becomes the owner of an account in a bit. Before we conclude the entry point section, there is one more thing to know. All accounts to be read or written must be passed into the entry point function. Let's bring up our code here. So this accounts here, this piece of data, it's an array, I believe. Account info is an array of accounts. Account info, really. This allows the runtime to parallelize transactions. If the runtime knows all the accounts that will be written to and read by everyone at all times, it can run those transactions in parallel that do not touch the same accounts or touch the same accounts, but only read and don't write. If a transaction violates this constraint and reads or writes to an account of which the runtime has not been notified, the transaction will fail. This allows runtime to parallelize. So what that means basically is we need to provide every account that is going to like be debited, so that the runtime, this whole Solana runtime, it's called C-level. It can it doesn't have to worry about hey, you debited 10 SOL from this account and now you're trying to debit 5 SOL, but there's not enough left because it happened in some other transaction. Now, to finally conclude this section, create a new entry point.rs file next to lib.rs and move the lib.rs code there. Finally, register the entry point model inside lib.rs. You'll have to do this for all files we create. Okay, so all that means is I'm actually going to cut all this code and put it in a new file called mod entry. Oops. It's giving me a grief because I don't have the entry point file created yet. We'll create that now. Entry point.rs. And then we're going to paste all our code here. And so this is just the code I brought over from lib.rs. Yeah. Okay. So that's good. Our lib.rs is just going to actually become a kind of a holder of all these modules as we go on. I think we're going to go through the theory recap together, and then I'm going to call this stream. I'm not sure if I'm going to hop on later or not, but man, this is good. I'm going to try to get some eyes on this to get some smoke check and make sure I got some of the concepts right. But it's been really illuminating for me just to go through and explain it. Theory recap. Each program is processed by its Bpf loader and has an entry point whose structure depends on which Bpf loader is used. So remember, I don't think we actually dictate here which Bpf loader is used. I think that might be defined by this module, the version of our Solana program, I would bet. Yeah. Accounts are used to store state. So that's our whole thing about how we don't when that escrow program is on the blockchain. It's not going to save every it's not the program itself is not going to save the state of the escrow transaction, right? Remember how our escrow had an escrow transaction, the whole flow of it has multiple steps. It's not going to store that in the program. We have to store that in an account. We have to store that state in an account. Accounts are owned by programs, so the account is owned by a program Only the account owner may debit an account and adjust its data. All accounts to be written or read must be passed into the entry point. That's what we talked about here. And we'll do that here where we pass all our accounts information. All right, we're gonna take a break. I'm not sure how long a break. I may be back today for a little bit of work because this is really fun, and I learned a lot, and I hope you're learning a lot. All right, so I'm gonna wrap up. This will be posted on YouTube very shortly. You're welcome, Bobby Starbuck. Glad to see you here. For some reason, I didn't know anybody was watching. Yeah, we're gonna post it on YouTube as soon as I can. Hopefully, in the next couple hours. Yeah, check out GROM's NFT if you haven't already. GROMs.club. Cool. Thanks for watching.